Hi everybody, I'm Thomas. I'm working at Monadic. Let's see how this works. Yeah. I'm working at Monadic and we're working on a project called Radicle, which is a platform for decentralized open source code collaboration. And our vision is to kind of bring sustainability to the open source community with the help of this decentralized platform and blockchain technology. And I want to talk a bit about how we are developing our runtime with Substrate, some of the challenges we faced, and the technique we use to kind of circumvent these challenges. Okay, so let's set the stage. We started using Substrate, I think, 2 months ago. And what my team is doing is basically building this small prototype of a blockchain with Substrate, and this blockchain is consumed by an application, a dApp, which lives in the browser but talks to some background service. And so what we deliver to this team is a high-level Rust client to interact with our blockchain so that the app can transfer money, kind of register these open source projects and stuff like that. How does the client look like? So, as I said, it's a Rust client, and the basic idea is that it looks like this, that you have a function for transferring, for submitting extrinsics or transactions, however you want to call them, and a function for getting information from the state. This is what I mean by high level, so it's not like that you need to compose your extrinsics or something like that. So I mean, the details don't matter really. This is the kind of the gist of it. So one of the challenges we faced is how to test this, and especially how, like, since we're in the very early stage, how to iterate on it very quickly, rapidly, and make sure that it's still working and that we can integrate with the app team from day one. And of course, what's the best way to do it is, if you're working with a different team, is kind of acceptance level tests. So what we test is kind of our contract with the app team and like with everybody in the company who's involved in designing the business logic of the ledger. So how do acceptances look like? Pretty simple. We test the client that we deliver. So we instantiate it. We assert kind of the initial state of the thing, which is a given recipient has no money in their account. Then we transfer some money out, and then we assert that now the recipient has 1,000 of this token. Of course, I omitted a lot of stuff. If you write this, actually, you need to use async await and do some setup and so on. But this is the high-level thing. And the nice thing about this is, like, people from the outside that are not involved in the project can look at this and say, yeah, that clearly maps to my mental understanding of this. So we kind of assert that we implemented the ledger logic correctly, but you also assert that the client that we deliver to the app team conforms to the expectations of the app team. But acceptance tests have a problem. And for example, if you come up with that idea and you start with it and then you think, okay, I'm going to use the client, I'm going to spin up a node to actually run the client. And then you quickly run into the first problem is that whenever you change runtime code, Substrate takes 3 minutes to link your binary, and to actually test it, you're waiting 3 minutes to run the test. I guess all of you have experienced this in one form or the other. Other problems are, of course, you cannot really run the tests in isolation unless you tear down the node on every test case and reset the database and start it up again. And there's some other issues with that. yeah, so the main idea is that acceptance tests are quite expensive. You need to control all the stack and then, yeah, set up and tear down. So what is the solution to this problem? First of all, one thing to consider is that what you're building and what you're testing is this code. But if you run this full integration acceptance test, then you're also running this code, which is the Substrate code. And I guess, like for us, this is not even to scale. It's probably like a tenth of this if you compare the code size. And so the basic idea is you circumvent this code and only test this code, but on an acceptance level. And what enables this is a thing, a structure called test externalities that you can find in the, as of 3 weeks ago, in the SRIO module. I think now it's the SPIO module, and I guess it's going to be something else next week. So there you find this struct that has a couple of very nice features. And this struct is actually used in all the tests for the Substrate runtime modules. What you can do with this is you create it, you need to pass it some parameters that I won't go into. And what you can then do is you can call this execute with function on it. Takes a closure, and in this closure you can call this function. If you call this function from the SRIO module in from any Rust code, then it's actually going to error and tell you, okay, there's no storage available. Because this expects to be run in the Substrate runtime when kind of the storage of the chain is available. But now with test externalities execute with, this kind of provides the environment for the storage, and you can write something to the storage, as well as here get something out from the storage. And so we use this to find our solution to the acceptance test problem. We create kind of a test externalities backend for the Radicle Client. So instead of talking to a full node over RPC, we replace the RPC communication with a call to the test externalities and make sure that it's very, very close to how the Substrate runtime is actually called. And the way Substrate is structured makes this actually quite easy, because the main entry point is, for example, I think it's called apply block. And this is everything that you need to call to kind of simulate what happens on your blockchain if a block is imported. So this makes testing super fast because we can run the tests in memory, we control the state, we can check different Genesis configurations, we can isolate test cases, yeah, and we use this for basically everything. And there's a nice side effect to this, or to using this technique. There's also something in it for the app team. For now, I just talked about how the team that builds the blockchain, the Substrate runtime, benefits from it. But there's also something in it for the app team. And this actually, we are still thinking about the name, but this is kind of a client emulator, or you could call it a runtime emulator. And what this does is we not only ship the real client to the app team that needs to, and then the app team needs to run a node and compile it and whatever, but we also ship this emulator, which looks like a client from the outside, but internally runs all the code with test externalities and kind of simulates the whole runtime without going through network, without needing consensus, without needing to wait for the blocks to be created and finalized. And so it's as easier for us to tell the app team, okay, here's this branch, You can use the client emulator. They start up this this one background process which provides the blockchain without any of the overhead that Substrate has. And that's it. Thank you. You can check out the code and how we approach this in this repo. You can find out more about what Radicle is under this address. And if you're interested in the project, we are also hiring. Thanks.
So we're actually a little ahead of time, so I think we can take one question for this talk, just one, if anybody has any. Give you a moment. Does anyone have any questions about this?
Well, I guess if you're interested, just come up to me and we can talk about it. Thanks.